So here I'm going to explain different types of addressing modes of 8051 microcontroller. Addressing mode is nothing but it's a method which is used to access the data from different memory locations. The location, it may be a registers, different types of register in 8051, or it may be a memory. It may be internal memory or external memory, as well as input output devices. In simple words, we can say addressing modes are references which are used to identify data. So we are having 5 different types of addressing mode. So first one is immediate addressing mode, second one is register addressing mode, and third one is direct addressing mode. Next is indirect addressing mode. And last one is indexed addressing mode. Uh, Let us consider indirect addressing mode, sorry, immediate addressing mode. The general format of instruction is first one is move instruction. General format is move, that is opcode, destination, comma, source. Here source, it's a number, that means the data. So whenever we are going to give number array data which will be a part of the instruction, we need to specify that with hash symbol, like for example hash 24h. So this is the data. Whenever we are going to write the data in instruction only as a part, we have to represent that number by hash symbol. So destination, it may be a different types of registers. It may be a register, or register from 0 to R0 or not to R7, or it may be a direct address also, or it may be a DPTR, data pointer. So let me to explain one by one different types. So first example is, so move a comma hash 12h. That means, so we are moving the number, we are moving the data, that is 12h, directly into the accumulator. For example, if the accumulator initially, before execution of this instruction, so before execution, accumulator, for example, if it is having a value of 10h, so after execution of this instruction, so this data, this number 12h, that will be moved to the accumulator, that is 12h. The content, the data present in the accumulator after this instruction execution, the value present, the data present in the accumulator is equal to 12h. So next one is move R0 comma hash of 24h. So here also we are moving the data, we are moving the number 24h to the register R0. So before execution of this instruction, let us consider the register R0 is having a data of 20h or 30h. So after execution of this instruction, so whatever data which is present in the instruction, that is 24H, that will move to the register. That means whatever the data present before the execution, that has been replaced by the data present in the instruction, that is 24H. This is the another type of immediate addressing mode. That means here we are having a accumulator as a destination. Here we are having a register as a destination. See here, in 80 microcontroller, we are having 4 blocks for a register. Each block will be having a resistors from R0 to R7. So 4 blocks, that is B0, B1, B2 and B3 register banks. Register banks. So B0 to B3, each register bank will be having a 8 registers, that is R0 to R7. For the selection of register banks, so we are going to use 2 bits of PSW, that is RS0 and RS1. So 00 is nothing but the bank 0 will be selected. 01 is nothing but bank 1, 10 bank 2 and 11 bank 3 will be selected. So by default 00 will be present in RS0 and RS1. Therefore by default only we are going to have a bank 0. Next type is move DPTR, 2412H. So here the destination is a data pointer and source is immediate address, immediate data or a number. As we know, DPTR is 16-bit register. If you consider this instruction as well as the previous instruction, so the data we are moving to the register is, this register is 8-bit register, and the data what we are moving to the register R0, it is also 8-bit register. See, in immediate addressing mode, the source as well as the destination both should be a same size. That means if you are going to move the data of 8-bit to the register, the data should be 8-bit as well as register should be 8-bit. So if it is a 16-bit data we are going to move to the register of 8-bit, it is not possible. Therefore source as well as destination both should be having a same size. Then only we can apply immediate addressing mode, or we can use immediate addressing mode. Here also DPTR is 16-bit register. So for that reason, so we are moving the data of 16-bit to DPTR. Or we can use, as we know, DPTR is divided into 2 register. That means lower 8-bit and higher 8-bit. Lower byte and higher byte. Lower byte is nothing but DPL and higher is DPH. You can address the each lower byte of DPTR also. For example, instead of using DPTR, 2412H, you can use the instruction DPL, hash of 12H. See here, as we are moving the data 2412H to DPTR, this lower byte value is there, no, 12, that will be moved to the lower byte of DPTR. That means, so here lower byte value, so 12 will be stored, and the higher byte value of DPTR 24 will be stored. instead of using 16-bit data to DPTR, you can use the instruction move DPL comma 12H. That means 12H should be moved to the lower byte of DPTR. Move DPH comma hash of 24H. So here 24 will be moved to higher byte of DPTR. Same result we are going to have while using these two instructions. In DPTR, 12 will be stored in the lower byte and 24 will be stored in the higher byte. So whatever the uh, result we are going to get after executing move DPTR, the same result we are going to have by using these two instructions. Difference is that the source and destination in this instruction is 16-bit, whereas in these two instructions the source and destination is 8-bit. That is the difference.